Hi, this is Mona. Welcome to my channel. This video is part of my beginners friendly AI playlist. If you're completely new, I recommend watching the whole series from the start. Otherwise, I recommend checking out my more advanced courses instead.
I'll go through 5 modules, each divided into 2 parts, where I'll cover the key foundational concepts you need to get started. Today, I want to clear up some confusion and explain difference between artificial intelligence, machine learning, deep learning, and data science. We'll also look at how these technologies work together to make things easier to understand. I'll use some simple Venn diagram and examples. First, let's start with artificial intelligence or AI. You may have heard about AI in the news or seen AI-powered tools like language translator or virtual assistant. The main goal of AI is to enable machines to think or make decisions on their own without direct human involvement. For example, AI is at the core of virtual assistant like Siri or Google Assistant, which can answer your questions or complete tasks for you because they were trained on voice data. In Netflix or YouTube recommendations, AI predict what you like based on your watching history, or in Instagram filter, AI detects faces and applies effects learned from tons of face images. Ultimately, when we build an AI application, we want the machine to act intelligently, like being able to drive a car or play a game. Now, let's talk about machine learning or ML, which is a subset of AI. Machine learning focuses on providing computers with data and statistical tools so they can learn from the data in a simple scene. ML helps machines recognize patterns and make prediction. And there are 3 main types of machine learning. In supervised learning, just a second, yes. In supervised learning, we train the model using labeled data. This means the model knows the correct answer during training. For example, if you have a list of houses with their sizes and prices, the model can learn to predict the price of a new house based on its size. The key point here is that the model learns from past and label data to make future predictions. Here, we use data in unsupervised learning. We use data that isn't labeled. The model doesn't know the correct answer in advance. The goal here is to find patterns or groups within the data. For example, you could give the model a set of customer data and could organize the customers into groups with similar shopping habits. The next one is reinforcement learning. This type of learning involves models that learn by trial and error, getting feedback based on their actions. Think of teaching a dog new trick by giving rewards over time. The AI learned what action lead to rewards, even if it doesn't have label data for every possible situation. Video games playing agents or robots learning to walk often use reinforcement learning. Now we have deep learning, which is a subset of machine learning, as you can see in this diagram here. And it's a way for computers to learn from lots of data by using systems called neural network, which are inspired by how our brain work. Neural networks help computers recognize patterns like spotting face in photos or predicting what might happen next based on past information. I'm sure you know that about spotting faces. As you can see here, it means recognizing or detecting people's faces in photo or videos. For example, when you take a photo with your smartphone and it draws a box around someone's faces, that's the phone's software spotting or finding the face in the picture using deep learning techniques. Now, does data science fit into all this? Data science is a bigger field that uses deep learning, machine learning, and math, like statistics and probability, to find useful information in data. Data scientists use these tools to solve real problems, like figuring out what customers think about a product or predicting when traffic will be heavy. To sum up, AI aims to create intelligent and or smart machines. ML as a part of AI teaches machines to learn from data. Deep learning as a part of ML uses brain-like networks to handle tough problems, and data science combines all these tools to turn data into useful solutions. Yeah, that's for this part of this series. And if you find this helpful, don't forget to like and subscribe. It really helped the channel. And if you have any question, drop them in comments. I'll happy to answer. In the second part of this video, I'd like to talk about some foundations of AI, specifically its limitations, safety, ethic, and when we use AI, because when we use AI, it's important to understand some core concepts. Let's go through them step by step. So be sure to keep going with me. AI ethics and bias. AI should treat everyone fairly, but sometimes it makes unfair decisions because it learns from biased data. For example, if an AI sees more picture of men doctors and women a nurse, it might wrongly assume that doctors are usually men. Or if a hiring AI is trained mostly on resumes from one country, it might unfairly reject applicants from other backgrounds. And another example is a photo app might work well on lighter skin tones, but fail to recognize darker skin tones simply because it wasn't trained on diverse image. Bias happens when AI reflect the pattern in the data it was trained on, and that's why fairness happens. Just a second. Yeah. So Joy Blowini, who researches how computers detect, recognize, and classify people's faces, introduces the concept of coded gaze, which is a term of algorithmic bias. Her personal experience revealed this bias when a system failed to detect her face until she wrote a white mask, and other facial analysis demos misgendered her. This led to Gender Shaded Project, an MIT thesis to investigate if this issue were a pattern or unique to her face. The project aimed to see how well different gender classification system worked across diverse spaces and if results changed based on a person's gender or skin type. For the study, she created a data set of over 1,000 images of parliament member from African and European countries to include a range of skin and type. She then evaluates AI service from three companies, IBM, Microsoft, and Face++. You can see more here in this URL here if you want to, if you're interested to know about the details. But here is the related, and I think in this a video is related to almost 7 years ago. But here are the key findings from the study as presented in that video. And it's while the companies appeared to have relatively high accuracy overall, with Microsoft performing Microsoft performing best at 94% accuracy on the whole data set. And all companies perform better on males than females. When analyzing results by four subgroups, all companies performed worse on darker females. And IBM showed the latest gap in accuracy with a 34% difference in error rates between lighter male and darker female. AI safety. AI should not cause harm. This is about making sure AI systems are safe to use in the real world. For example, a robot vacuum might bump into a sleeping pet if it can't recognize it. Safety features like pet detection can prevent harm. Or a smart home AI controlling your thermostat or door locks could malfunction or be hacked, making your home too hot or too cold or even unlocking door by mistake. Another example is self-driving cars need safety checks. Imagine if the car doesn't recognize a cyclist at night, it could cause an accident. That's why testing and safety rule are so important. AI is powerful, but it cannot do anything or everything. It cannot do everything. It struggles with things it hasn't seen before or with tasks requiring deep common sense. For example, a language app might not understand slang or joke or sarcasm, and a chatbot might give a confident but completely wrong answer if it doesn't know the right information. Remember, AI never says I don't know. And another example is an image AI might confuse blueberry muffin with a dog's faces in a picture. It sounds funny, but it happens because they don't see image like we do. They look for patterns of color, textures, and shapes or pixels. In early AI systems, I mean in 2015 to 2017, this was a common issue, and researchers use funny examples like a sheep versus clouds to show the limitation, to show the limits. For example, the dark blueberry on a muffin look like a dark eyes or nose on a maybe dog's faces or yeah, and the tan muffin surface has similar colors, a dog's fur. So if the AI hasn't seen enough examples of each, it might confuse the two and label the muffin as a dog or dog as a muffin. AI isn't perfect. It's a tool, not a human brain. And another topic is privacy concerns in AI or AI and safeguarding. AI often uses personal data, which must be kept safe. For example, a voice assistant shouldn't share your private conversation with others, or a fitness tracker collects health data. It must be protected so no one misuses your health information. Or social media AIs analyze what you like or watch without safeguards. The data could be sold or misused. Protecting data is key to keeping AI trustworthy. But how can we make sure data is safe? AI has encryption, which means data is scrambled, so even if someone steals it, they cannot read it without the key. Also, anonymization. AI can use data without storing personal details. For example, it says age grouped between 20 to 30 instead of John, 25 years old. Another factor, is data minimization, means collecting only what is really needed. For instance, a weather app doesn't need your full name, just your location. Next is access. Access control that says only authorized people or system can access sensitive data. So what else should we think about? We need to know about user consent, transparency, regulation. What I'm trying to say is that you should know when your data is being used and be able to say no. Companies should clearly explain what data is collected and why. Additionally, laws like GDPR in Europe or CCPA in California are designed to protect user by limiting how companies use personal data. So practical tips for everyday users could be check the privacy settings of AI apps like voice assistant or social media. Avoid giving away unnecessary information. If an app asks for your phone number but doesn't really need it, don't share it. And use strong passwords to enable two-factor authentication where possible. Ethical AI means using AI responsibility in ways that benefit people. Um, for example, being honest when a chatbot, not a human, is answering you. Using AI to support education or healthcare, not just to make profit. And making sure AI tools don't replace human unfairly, but instead help them to their job better. Ethical AI is about transparency, responsibility, and doing well. The next one is um, personally identifiable information. PII is information that can identify you, like your name, address, phone number, email, or even a photo of your face. For example, if an AI app collects your phone number, it should not sell it to advertisers without permission. Or if a school AI system stores students' data, that information must stay private and secure. Even your browsing habits or GPS location can count as PII if they can be linked back to you. Protecting AI helps keep your identity and privacy safe. So before closing this module, I'm going to show you three really fun and friendly AI powered tools. You can try right in your browser, no coding needed. they're interactive and visual and perfect for beginners. So let's dive in. The first one is Teachable Machine. You can go to teachablemachine.withgoogle.com. It's by Google, and this cool tool lets you teach a computer to recognize things like image, sounds, or even poses without writing any code. You simply, and as you can see, I click on get started, and there are three projects here. You simply upload or capture example data like photos or sounds, label them, click to train, and boom! You've just made a machine, a learning model that can classify new inputs. Um, It even shows how confident it is in guesses, all visually and super beginner friendly. It's a fast, easy way to create models with no coding needed. So let's start it with image project, and there are two options: a standard and embedded image model. I want to show you how a standard image model works. There are two classes here, and a training model and then preview. And also you can add more classes to your model. For a start, I want you can upload the photo from webcam or upload from your system or even from Google Driver. I want to upload some images from my local system. For example, I choose three dogs here, and then I'm going to upload three images for ball. For example, this one, and also this one. Okay, and then I click on train model and wait for it. And also here there are two options, file and webcam, but I want to continue with the files, and choose image from other images like this one. I want to click on it, and as you can see, it's in class 1. And also I can upload another image as well. For example, I want to upload this image and understand how model recognize it. And as you can see here, it's in class 2. 100% is in class 2. So another one, let's check out AI for Ocean on code.org. And this interactive lesson designed for young learners teaches the basics of AI and machine learning, and even bias in a fun way. Here, how it works: you feed the system training examples like distinguishing fish from trash in the ocean. As you add good or bad data, the AI learns or makes mistakes, showing how important quality training data is. And it's a great way to see how AI works without knowing how to code. Here, you as a beginner learn about training data, bias, and AI ethics while teaching a bot to classify fish versus trash. And actually, this is the AI. AI doesn't know if an object is a fish or trash, but it can process images and identify patterns. To program AI, use the button to label an image as a fish or no fish. And the training you provide will teach AI to recognize the pattern on its own. Let's start. This is not fish, 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 fish. And here is the informative. Yeah, no, yes, no. And that's it. I want to continue, and let's see if AI knows what the fish look like. Actually, the more photos you give it and the more training you give it, the better it can differentiate. As you can see, we didn't train to AI that this part, for example, this apple is It wasn't in our data set, and that's why it recognizes as a fish. So that's enough, and I want to go through another one. The third one is, and finally, is Quick Draw. It's again by Google. Um, it's a fun and almost Pictionary style game from Google's AI. Experiments, you get 20 seconds to draw an object, and neutral neural network, sorry, a neural network tries to guess it as you draw. It's engaging and hilarious when the AI gets it wrong or right in surprising ways. And the best part, each time you play, you help train the AI further. It's AI learning in action, and it's captivating to watch how it gets um, from something to something more recognizable, something squiggles to something more recognizable. Let's start. I'm not good at drawing, but let's try together. I have to draw a flag. This one. Okay, hopefully it understand. And I have to draw a piano. Oh my God. Yes. Yes. Eraser. I don't know how to eraser. Oh my God. No, it's not hot. Toothbrush. No, it's not. Yeah. Fortunately, I don't know. So, wine glass. Okay, let's try it. And oh my God. Yes, that's true. Garden hose. Oh my God. I think it's too hard. Um, yeah. Triangle. Let's try it. Yes, and as you can see, there is a result here. Um, Also, another thing I want to mention that I click on data link, and here you can see that there are 5 million drawing look like, and how they look like, and there are some drawing, and I think they are the best. But if you, for example, click on this, I like this one. It's a bear, and if you click on it, you can see that a lot of people tried to write a bear here, and you can improve your confidence. Yeah, and look at this one, or and I like this one. So that's it, and so there you have it, three beginner-friendly AI experiences. You can try yourself. Teachable Machine to create and train your own model from image, sounds, or pose. AI for Ocean learn AI basics through a hand-on, ethical, focused activity. And Quick Draw, play while the AI learn and improves with each of your sketches. All of these are web-based, free, and require no programming skills, just curiosity and a willingness to play with tech. If you try a try of any of this, drop your experience or funniest AI guesses in the comments.
I hope this video helped you understand the infrastructure of core concepts in AI. If you found this helpful, don't forget to subscribe to the channel and share it with friends who might be interested. See you in the next video. Bye.